So today we're back on data mining. Business intelligence, knowledge management. I really should just change the slide and just make it data mining. But big adventure for today. First, we start out with the fun questions from last week. You guys have any questions from last week? Do you remember what we did last week? Today, you got an assignment to do about it. Like, hopefully you took your quiz about it. You got an assignment to do about it today. So hopefully you have a little. Have any questions about your assignment, your quiz? Really? Okay. The big plan for today is going to be, we're going to do a little show and tell. So I hope you've at least started on assignment 2. I looked and a whopping 3 of you have turned it in. It's not just a midnight, you're too. You've got time. We're going to do a little show and tell for assignment 2. We're going to talk about the concept of variable selection. So we're going to talk about linear regression with the idea of prediction versus explanation, and do a little bit of transition talk there. Then the whole idea that why I'm using linear regression as our first thing, and hopefully you already know it at least a little bit, because I taught it. It's using as an estimation technique for us to talk about model performance, and that'll be a big part of our model performance. I have discussed projects. Really the only thing there is just checking in with you guys. We all have our team set up. Everything's good to go. As you see, we help on your data set. So that's kind of our big thing for today. So, where have we been? Just making sure that we're good with all of our verbiage. We've got 2 different data mining processes that we're talking about. And we have 2 different categories that we talked about, 2 big categories. And so far within our categories, we have different tasks. Right? The estimation, the classification. Those are the 2 big ones we focused on. Then we'll have clustering, association, and description as well. So far, we've talked about, what have we talked about? Right, we've hit this. Right, we like the CRISP process. In fact, I'm going to encourage you to use the CRISP process as you start assignment 3. We talked about our different data mining categories. So far, we've really done an unsupervised task. And you guys were focusing on visualization. So we're in the unsupervised category with the description task. It's kind of been where we've been at this point. Today, we're going to still focus on that CRISP process. We're going to hit our first supervised, and we're going to focus on an estimation task. So that's going to be today. So where we've been? We've really been doing the data understanding and the data preparation phase. Right? So we've been assessing the quality of our data. Obviously there was errors because I put it in. We've been performing some exploratory data analysis via visualization. Hopefully for this last assignment you were fixing your errors, so you were in the data preparation phase, you were cleansing it, you were preparing it. Probably not ready to transform anything yet. We haven't gotten to a point where we need that yet. And then this is actually what we're going to work on today, is selecting the variables that are going to be appropriate for our analysis. That's going to be our variable selection piece. Like I said, so far, and this is one of the slides that we'll just fill out every week. So far we've done unsupervised visualization. Today we're going to add in that supervised multiple linear regression. So where we are today, like I said, variable selection, linear regression, model performance. These are our big 3 things. We're going to be hitting the business understanding phase, the data prep phase, the modeling phase, the evaluation phase. All of those things we're going to talk about in context of linear regression today. But before we get to that, sometimes I just like to pause for effect. Questions for you guys. So we had assignment 1, you guys all found the error in the data. For assignment 2 this through tonight, you've been cleaning your data. And so one of the questions I have is, how did you clean your data? Excel. Okay. So what did you use Excel? Anybody not use Excel? information on it, Python. Excel, Python, SAT, nobody wanted to play with that. That's okay. It doesn't break my heart. Okay, maybe it breaks a little bit. No, I'm all for using the tool that works the best for what you need to do. Right? So you have a small data set. You're familiar with your Excel skills. Go ahead, use Excel, fix what you need to fix, move on. Right? We'll learn how to do different things in different software as we go. How did you add your new variable? Excel. Anybody do anything besides Excel? Equals this column plus this column plus this column. Okay, great.
I use SASFly, but then realized that I have to redo it in all the tools. So.
And so that's a fun point. He makes a very good point. So I'm like, hey, try all these different softwares, but then you're like, well, yeah, but now I'm data cleaning in this software, and I'm data cleaning in this software, and I'm data cleaning in this software. So ideally, so at the beginning and kind of why we were doing assignment 2 was really just to get you familiar with the softwares. That was the goal. If you came up with amazing visualizations, that's great. If all you gave me were bar charts, that's okay too. Yes. Okay. So the point for this assignment wasn't major insights, right? It really was, let's take something simple that you guys are familiar with, and you know what looks good and what doesn't, and let's look at the different softwares, get acquainted with them, and be like, I'm not going to use Enterprise Miner to make visualizations because, ew. Is that a consensus? Yeah. Right? Enterprise Miner is just not the thing.
It wasn't very, intuitive.
So it wasn't intuitive. And on top of not being intuitive, how'd the graph look when you were finished? You're like, I would not show this to anyone. Okay. So do show it to me. I want to see at least 2. Okay. But if they're horrible, that's okay. So like I said, the point for this was just something very basic, just to get you into the software, get you working with it. And that really was the point. It wasn't necessarily to come up with the biggest, best, brightest visualizations. But saying that, so that's our data that we were playing with. We were playing with our trend data. What I actually want you to do, just for a few minutes, is I do want to see what visualizations you came up with. Okay. So out of all the playing and all the things that you've done, if you will get into Blackboard, and we're going to take about 10-15 minutes to do this. I promise it becomes more interesting. Okay, so if you'll get into Blackboard, somewhere in the course that you guys are in, on the discussion board, you'll find a forum for classwork. So go ahead and get into the classwork forum. And then I've started a thread that says visualizations with today's date. Go ahead and click on that one. And then really what I want you to do is I want you to reply to this thread with your favorite visualization from assignment 2. So hopefully by this point you've at least done one. What I recommend that you do, open up your assignment 2, select a visualization, save as somewhere, save on your desktop, save it somewhere easy real quick to look. And then when you reply to this thread, and you can select down on the bottom, the second one over, it says edit image or insert image, and then just insert the image. I don't need any text, I don't need anything that goes with it, I'm just looking for the visualization. And if you'll wait for 1 second, let me fix one thing before we do this. Did you already do it? Don't do it. Deciding which visualization you think is your favorite. So now you should be able to go into classwork, go into visualizations. And this part is totally up to you. When you reply, you're going to insert an image. And then if you want to, you have the option to post this message as anonymous. Okay. So if you just want, if you want to put your name out there and be like, yeah, this is mine, put it out there. If you're like, I'm just doing this because I have to, you're welcome to post the message as anonymous. Okay. So this isn't going to be a graded thing. It's going to be more of a, you're here and you're participating, and I'm going to count and make sure I have 20 of them, and life is good, right? But I just kind of want to see what kind of graphs you came up with, what kind of visualizations you came up with the different tools.
So you don't need to make any comments?
You don't have to make any comments, just the visualization is going to speak for itself.
For better or for worse?
For better or for worse, the visualization is going to speak for itself. Alright, so whenever you're ready, go ahead and start replying. Again, if you want to make it anonymous, you're welcome to do that. So I like the active. Kind of see what insights you found. See if people were really creative and started putting a lot of things. Yeah. See if y'all stuck with the handy dandy bar chart. Alright, we're up to 7. We're doing good. Should I do it?
No.
I'll do it.
Oh, you can do whatever you want.
I'm definitely anonymous.
I feel like she could probably see. Like, I was just
Alright, we're up to 10. We're getting there. So just reply with the visualization. Any of them, whichever one's your favorite. And we'll just start kind of looking at them, because that's the fun part. So some of them will pop up in here, some will pop up and we'll actually have to click on them, but that's okay. My thought here is several fold. I'm not going to look at all of them yet. We're going to wait till everybody gets. Start to 12. We're getting there. Need about 8 more. I still hear some clicking, so we're good. Kind of the goal here is I ask you for your favorite visualization, so we'll see which software people are like, this is the one I like. We may see just, again, it may be simplistic. We'd be like, this is the thing that had the key piece of information.
Yeah. I mean, like maybe the most honest. I like the stuff that I was my favorite. I got mad at the idea or it didn't center it, so it's
Alright, 13.
on space 12. Yeah, like half of them were centered and the
Does
other.
anybody have any issues uploading their? See, look, you guys are already looking at them.
I'm sure they're actual.
Nope, slow it down.
Oh yeah, Courtney, I made it bigger. It doesn't show anything. Oh, it does.
Alright, one more. We're getting there. I'll give you guys about 1 more minute to get it all posted. Let me know if you need help. go back into our forum, and you guys are going to be able to look at it. And look! I don't even have to give you directions, and you're already starting to give like little stars. So no, you don't have to rate them. But you can if you want to. So as you're going, especially if you find and you're like, oh, I really, really like this one. You know, give it some stars. You're like, oh, no, this is not it. Okay. The stars mean absolutely nothing other than, hey, we like this visualization or we don't. But so let's kind of look at some of these. So here we have a box and whisker plot with a bunch of dots. What do we think about this one? So it's made in Tableau, so Tableau's a good one. Do you like the box and whisker plots? So we're talking about the number of international calls and if they have an international plan or not. What's something you really like about this graph?
It shows that there's no kind of normal distribution.
Okay, so you're kind of... So you're getting the distribution. Nice and kind of evenly spread out. I actually kind of like that you have little dots as well, instead of just the lines. I really like there's a title. This person actually took the time to put a title in with it. So whoever you are, anonymous. Okay, let's try another one. What do we think about this one? Average charge by state. So again, we got a title. I know what I'm looking at now. Do what?
What's going on in Indiana?
What is happening in Indiana? Okay, so we got the darks over here in Indiana, looking a little maybe Maryland. So my question that I posed as I was grading these for my Saturday class is, how important is Alaska and Hawaii to your visualization? Right, it's like Alaska, and in the rest of the United States. So if you have data about Alaska and Hawaii, can you choose not to use that data when you're making visualizations?
Yeah.
Somebody may be offended.
Somebody will be offended. Right, so this is...
Someone in class who can get
I've got family there. I sympathize with you, right?
Alaska
Can you
is
like
so
have
big
it
and
a subset?
You could, yeah.
It's not that.
So like sometimes people will start to, you'll see like Alaska, and you'll cut it and it'll be like in a little box off to the side. Or Hawaii off kind of like right next to each other off to the side. And that's the crazy thing about the US, right? There's not a lot of other countries who are split with another country in the middle. Right? So this is why you'll see a lot of things that are just of the contiguous, 48 states. And we're not counting Puerto Rico because it's weird. But yeah, so that's just one of the things to think about. Just because it's in your data set, if it's not helping your story, right? Because there's anything interesting happening in Alaska or Hawaii, right? If it was, right, like if Alaska was the darkest state, you can't leave that off, right? But since it's just kind of in the same colors as most of the others, maybe for your visualization so you can see the states better. I'm not picking on you, you just have to be the first one with
you're
pictures.
good. Just help me when I start.
You're like, yes. And that's kind of the idea too, right? These are some of the things that I picked out from the Saturday class. So we're going to talk about. Also, not going to lie, makes my grading go faster. You guys fix things. All of your assignment 1 should be graded. Some of them were graded, well, at this point, 45 minutes ago. But all of your assignment 1s are graded. Everybody did really well. You'll see some comments on some of them. If it has a reference to A2 and you fix it, great. If not, and I just gave it back to you this morning and you don't get it fixed, that's okay too. What do we think about this one? Things we like, other things we'd like to see added.
It's kind of hard to tell what's happening in space.
Okay, so over here the bubbles are overlapping, we're not sure what's happening. So what is the bubble representing?
charge total.
Okay, so is it customer service calls? Is it the charge total? So what?
The color is the side. Yeah, the color is the charge, and then the size.
Okay, so the color is the charge, and then the size is the number of customer service calls. Is there a way to make that more clear?
I don't even know if it's possible with whatever they use for this, but I feel like taking the names of cities off the map would let clutter less.
Okay,
Make it a little bit easier to see.
so maybe we don't need to see quite as much detail. Like, and yeah, in Tableau it's like, yeah, you can, it just does what it
This is
does.
satisfying.
Oh, this is what? Sasvaya. Okay. So in Sasvaya, then I have no idea except for like that enough. That's a great question. See, and then there comes the great question. And this is something that we're going to deal with throughout the course of the semester, but we're going to focus on. You have the picture in your head, and I've talked to a couple of you about this. You have this picture, and you're like, I know what I want to do. But the tool that I have in front of me isn't letting me do it. Right? And that's one of the things about great visualizations, right? So Tableau is going to be great to do a lot of things. SAS Via is going to be a lot more visually appealing than you're going to see Enterprise Miner and SPSS. But if you have a picture and you know what you want to do, a lot of visualization, you'll actually see people go out into like an Adobe type of environment and create their visualization as a true visualization. That's not going to be something we're going to focus on here, but if there's something that you know you want to do, make a note of it, let's talk about it, let's see if we can either figure out how to make it happen in the software we have, or, again, I talked to a couple of you and it was like, you know, Excel actually gave me the visualization that I want. Right? Tableau's great, but it wouldn't do this, and this is what I want to do, and I know I can make Excel do it. And that's okay too. Okay, so really we're trying to figure out what visualization is going to communicate the information the best, and then finding a tool that will help us do that. Alright, let's see what else. Scatterplot, charged by the number of minutes. Feeling pretty comfortable about that one. Scatterplot of selected measures. Good that it's a scatterplot, a little less informative, right? So trying to make sure that you have a good table or a good title. And again, not necessarily for this assignment. You don't have to, you have your stuff done, don't go back and just do it just to get titles. Okay? But in the future, as we're doing things, make sure we have good titles. We have our labels or axes labeled, so that's good. So customer distribution by state. So how is this ordered?
Frequency.
Yeah, so we got frequency, right? So we've got largest to smallest, which was one of our Gestalt principles that we talked about. So the states aren't in any order, and that's okay. We've got churn 0 and churn 1. What does churn 0 mean? Churn 0 is false. What does false mean? They stayed with this. So as we start to do visualizations that we're going to present in like final reports, churn 0-1, probably not the way we want to go, right? We want to make it where somebody looking at this and isn't as familiar with our data, it's very clear what's happening. And what do you think this pink's all about?
I kind of like it. Yeah.
Okay, so there comes the next question. Do you like having pink versus a white
I
background?
feel like it gives the graph a nice Florida vibe.
That's Florida. And a little
I like the
sunset in the
sunset,
water.
yeah.
I gotcha.
Teal, orange, and pink is very Florida vibe.
I mean, I think it's still kind of like a sunset on an ocean.
Okay. I'm not for it or against it. I was just curious what you thought were.
Like this one.
It's like, no, let me tell you.
Hold on. Can I explain or try to explain it? Or do you want to?
Go for it. Go for it. So what are you thinking, and why is this the one you picked?
Well, it looks really basic. Maybe it is, but so it's like using the web node node on the SPSS. And so I thought it was interesting. Again, I don't think it looks that great, but to me it was the most interesting graph that I was able to come up with. because it basically shows the relationship between like two categorical variables, in the sense that like the darker lines mean that like there's a stronger relationship like within the data. So for instance here, like the strongest relationship is that customers do not have an international plan or a female plan. Like that's what occurs the most. So like the business question would be like, are customers buying both or one or the other? And that's how you should see it.
And so this was great, right? Like, yes, it may not be the most visually appealing, but as far as informative, this is awesome because how many of you guys have been wanting to do correlations between categorical variables? Right? You're like, I know there's a relationship. I'm like, but it's not really a correlation, or at least a correlation that we deal with. You know, so this is like the perfect way to represent a relationship without it having to be a straight up correlation. Okay, so that was really great graphic. Okay. Again, probably not a visualization you would show someone necessarily, but at the same time, you almost could.
Yeah, I think you just want to make it look a little more geeky.
Not SPSS.
Yeah.
Right, but the idea behind it, you can turn into a visualization on a slide, you know, with big voicemail, big note, yeah. All right, so I'm loving this right here. What is that? Right, but this is perfect, right? Because it's the same illustration of right here. I don't know what's going on because I've got Alaska and Hawaii. But when you take Alaska and Hawaii out, you at least now see all the dots on the different states, and it's not just a blob. Right? So knowing when to have Alaska and Hawaii, when not to. When to zoom in on the Northeast. If something interesting is happening there, even if you've got data out here, you can make multiple graphs to show what's happening. Right? So here we're talking the size of a circle is the frequency again. This would probably benefit from a little bit more of a title, which we've been talking about. I'm seeing a lot of, ooh, so what's this one? This bio? Tableau? I'm seeing a lot of Tableau here.
Yeah, we know it.
And it's pretty neat. Right, so nice. So total charge, this is your count of charge total. So this is your frequency. And this is, might be nice to have an x-axis. Right, but it's nice we can kind of tell what's happening here with the total charge. Another Alaska-Hawaii issue.
Would it be nice to filter and show the top 5 or 10 problematic states?
Absolutely. That's definitely a way to deal with it. Right, so you can do, like if you know exactly what your question is, and you're interested in, well, let's see the top 10, the top 5, where we can really start to look. Then you can just like exemplify. So instead of having to have degrees of red, you may just have 5 red states, or 5 blue states, or 5 purple states, whatever. So I like that somebody, like the default I think is blue, somebody here made it red. So let's see if we change something. We love the circles. Lots of circles. Circles for frequency. Right, and so here, well, I mean, what is your big story that we're hearing here? So this is the frequency of state, the frequency of, do you know what it is?
I guess it's how many times this, well, I guess how many customers have a phone number as that state.
Okay, so this is really just a frequency of how many people are in the state, right? So this is actually great, so it's really showing you that you're really distributed throughout the U.S. Right, so those area codes or those customers are very well distributed all throughout the U.S. There isn't really, California's teeny tiny, but everybody else maybe a little smaller in Iowa. Right, but for the most part, the circles are fairly similar. Okay, so we've got the average churn, so we're looking at if you churn versus not churned. So again, we've got true and false, and if we're starting to do the visualization, true and false works great. 1s and 0s are essential when we're going to try and do our data mining or modeling. But when it comes to visualizations, you could actually change that churn variable to be left company or stayed with company. Right? You control your data. You could rename your data to make your visualizations more informative. So we've got average, cust, serve. Maybe if we could, and I don't know if we can, so I'm just throwing the maybes out there, right? Maybe stretch this out a little bit so we could actually figure out what av, cust, serve might actually be.
It's interesting that there's essentially no real difference in charges between the customers that left and those that stayed.
And that's actually, I'm hoping to see, and I haven't seen it yet because you guys have been a little more with the visuals, right? Did you use the average? Did you use the sums? Like, what metric did you use? Right. You guys had most of you guys had Dr. Wang last semester, so she kind of stole some of my thunder on this part, right? But what metric do you use as you're making your assumptions? Because you're going to get two totally different stories if you look at the average versus if you look at the total. Oh, we clustered.
Yeah, so I guess kind of like, well, I thought this one was most interesting, not necessarily to show to people, like for like in a business presentation, but it helps me kind of visualize what things are connected and like grouped together. And so like for me, the most relevant was the account length is linked to evening calls and international calls.
Oh, that's a fun information. And I like that, like, so here the calls are over here, but evening calls are up here, but evening charge and minutes are down here. Sometimes the calls are connected, and sometimes, like here, it's all about the day. That's a pretty interesting. And we'll do clustering in about 4 weeks. Get to this evening.
And as far as enterprise monitor,
that was the best I could do with that one. Perfect. All right, so here, so now I've got a day-night combo. All right, so we're both looking, so we're looking at day charges on the left, night charges on the right. They're on the same scale, so that's good. By state. What's one thing that you notice from this? And it's anonymous, so I can pick on anonymous.
Leave the W in.
yeah.
So right there, we forgot to do our data cleaning. Right, so that WN, that Coast Guard, excuse me, the Coast Guard code, left the data cleaner, left that in. Now, if you're using your visualization as an exploratory thing to find things like this, it's perfect. You're like, something looks a little weird. I need to go back and look at my data and figure out what that is. That's great. All right, let's look at a couple more. That's just informative, but that's the last one.
I think some are not loaded.
Oh, do I need to do some more? There are more. And so yeah, so informative, interesting when it comes down here. Some of our customers we kind of got this normal distribution of how long customers stay. And then we can start to decide, is that a good thing or not a good thing? Right? Here it looks like we're keeping people for about 100 units, whatever those units are. And then we're gradually starting to lose them. So how do we keep that or at least shift it higher? So we got customer service calls by count length, sized by frequency. That's a lot going on there. So customer service calls.
Basically, I'm trying to see if there's any correlation instead of scatter plot. Just thought more details in case there's a correlation, but there's no correlation, so we don't have to look.
So yeah, so really no relationship, which is great. Same thing here though. You got that wonderful little negative value way out here. So I was like, ooh, gotta go fix that one, fix this guy. Girl, died, person, number. I always default to the word guy, and I always feel really bad about it. And then here we're looking at charge total. Right, so nice kind of seeing how our charges are distributed, and that's pretty great. Do we like how specific these values are? $74.18.4. A little weird. Hard to change in Enterprise Minor. Yes, it is. Right. But so something that, like, as we, like, if we were going to do this, this may be something that I play in SAS Enterprise Minor and I kind of see what's going on. But if I'm actually going to present this, I go to Tableau or I go to Excel or I make something that has like the graph the way that I want it to look. So a lot of what I wanted you guys to do is, first of all, thank you for participating. A lot of what I wanted you to do is just kind of see what was happening, see what you could do. Right? So I use a lot of these visualizations, and Will made a perfect point. It's like I wouldn't necessarily show this to someone, but it's great insight, and now I know where to go with it. Right? Kind of the same thing here, right? I wouldn't present this, but I check it, make sure everything looks good, and it's a lot easier to visually check than it is to follow some of our, just like look through raw data. So how was that? Worth it? So a little bit of show and tell, a little bit of thoughts if you want to tweak your assignment. Don't forget to turn in your assignment tonight at midnight. Questions, comments? Visualization. So as we go throughout the semester, one of the things I'm going to try to incorporate a little bit better is what would be a good visualization to represent these results. Okay, so in some cases, the software is going to provide the visualization for us. In some cases, it won't as much. So we're hitting multiple linear regression today. So what do you think would be the best visualization to show some of these relationships? So like, let's say that we're trying to see if evening minutes and evening whatever can predict evening charge. Right. What would be a good way to see how the variables are related to one another? Scatter plots, right? Scatter plots really, as we're dealing with continuous variables that we're trying to estimate, scatter plots really are a good go-to visualization. Okay. Once we have predicted values, then we can potentially make a bar chart of our predicted values to see how the distribution looks. Okay, the scatter plots are a really great way visually just to kind of do what we're going to do today. So I have the idea of let's create the churn story. I don't really remember what I was going to do with this. The idea kind of here was you're starting to have this story in mind, right? What do we know about these customers? We've kind of talked with this through the visualization. Right? We're looking at sums. Did anybody actually calculate the percent of churn customers versus non-churn customers in your data set? Right? Was there more churn or more stay with the company? There's much more stay with the company, right? It was like a 20-80-ish, right? 15-85 or something, right? So it's a 20-80%. So how does that play into your mind as we're going to go forward? Okay. I really just don't have the timing for this one at all. We'll move that slide a little later. So what I want to get into for a little bit is some of the linear regression and some of kind of the business understanding. What are we going to try to do? So we're going to stick with, I stick with the churn data set. So we're sticking with the churn data set for the next 2 weeks. So assignment 3 is going to be a 2-week assignment. It's going to combine linear and logistic regression together. Okay, so instead of having to do one assignment on linear and one assignment on logistic, the idea here is you've looked at your data prep in assignment 1, you've explored your data, you've fixed your data, you've cleaned your data in assignment 2. For assignment 3, now we're actually going to model our data. We're going to model it using estimation and classification techniques. Okay? So today we're going to kind of understand, and my question, as simple as it is, in our data sets, do we actually have the day charge per minute? I don't think we have that one, right? So if we go back, right? So we have the day minutes. Oh, we do. We have the day minutes. We have the day call. We have the day charge. That's like the total day charge. But we don't actually have the charge per minute, right? So way back in the day, that's actually kind of how plans worked. It was this many, this many cents per minute for a daytime call, and this many minutes or cents per minute for an evening call. A lot of the times you got night calls for free. That was a big marketing thing there, right? Or it was this much for a nighttime call. It was this much for an international call. But we don't actually have that piece of information. So could we create it based on the information that we could have? Okay. So that's what we're going to look at, and I know it's kind of simplistic, but just kind of to understand what's going on. Like I said, these first kind of weeks are just getting you into the idea of what we're trying to figure out. So our other question that we're going to answer is, what's the international charge per minute? Is there a difference between day charge and international charge? And then does that charge change if you're enrolled in an international plan? Like, to me, that was a big question. Well, if I'm going to enroll in this plan, the whole reason I'm enrolling in the plan is so that I get probably cheaper international calls. Okay. So I'm not saying that I had these slides from last semester, but maybe I had these slides from last semester. I changed them a little bit. I just left this as a reminder for you. So step 2 was our data understanding phase. Hopefully by now we understand our data pretty well. Step 3, we're going into the data preparation phase. And so we're prepping our data, we've cleaned our data. So now I have a new data set called churn clean. So instead of churn dirty, now we have churn clean. So for your assignment, you're welcome to stick with your churn dirty set that you have cleaned on your own, or you're welcome to use the churn clean data set. Either one, doesn't matter. So we've kind of understood our data, we've prepped our data. For this point in time, we're going to say that our data is going to be prepped and clean, and we're going to be happy with how it is. In a couple of weeks, we'll talk about a couple of different other things that we can do to prep it, but for now, we're going to say linear regression, we're going to leave it how it is. So then we're going to get into the modeling phase. The first part of the modeling phase is going to be variable selection. And really, without calling it that, we've already done this. We did this last semester, right? When we started doing our multiple regression, we tried to figure out which variables did we want to keep in our model, which variables did we get rid of in our model, right? We talked about the idea of multicollinearity. Okay. Not as important this semester, but we still want to keep it in mind. For us, we're going to have to worry about the idea of overfitting. Okay, so our goal this semester, when we're doing regression, is to be able to predict what's going to happen. Right? So we've talked about overfitting a little bit in the first week. Right? Somebody want to tell me how you would explain overfitting?
When you change your data, or your output, so it matches what you think it should be, or what results you expect. Remember you showed us a graph, and there's one way that the relationship was, but then you changed the graph, the points in the graph, so it matched a better curve, or you changed the line to match the way the points were on the graph.
A model which very sorry.
Say the
model which closely follows the variables instead of the trend. Yeah. So this goes with each variable rather than going to the trend.
What if we had height as one of the variables which happens to be there in the data set, where we are trying to predict if customers are purchasing, and then the model says that tall people are all buying, so so the model starts to account for that variable.
Yes and no. Yeah, yes and no. Because that's kind of the idea, and that's why you have to keep that's more of a reason for multiple models, like continuous model update, as opposed to overfitting. Because you can have a good model that doesn't overfit, but it models so well that eventually it'll take other variables into account, and so you need an updated model to make sure that you're actually capturing the things that you want to capture. So I kind of like the way that Harry put it, right? So model follows it, just following, I use data points instead of variables, right? So it's following the data points and not necessarily the trends. Right, so kind of, I think Courtney was kind of the picture that I drew. Right, kind of something like that. And so we like the idea of trends. Yay, that's the basic idea. But the overfitting piece is when I kind of like connect the dots. I mean, I can make a function that does this, right? It would be a, what, 1, 2, 3, a 7th degree polynomial. Okay? I could make this happen, and I would get this data really, really accurate. I could explain a lot with a 7th degree polynomial. Sorry, I'll drop some algebra there. But I wouldn't necessarily have a trend. So if I picked a new variable, and here was my new variable, instead of saying, oh yeah, let's estimate it here, we're going to say, let's estimate it here. It's a big difference. And so the whole idea, and so with the dimension reduction, one of the big things we're going to try is we have a lot of variables. When we're trying to make predictions, do we want to have a lot of variables? So a lot of data is a good thing. Right? More data will often lead you to better predictions. But when you have too many variables, now you have the collection issue. Now you have the potential of errors. Now you have to figure out how to model this. As you start to try to explain this and use it practically, if you have too many variables, this gets a little crazy. You've also got the computation time. If you have a lot of data, you've got a complex model, the computation time is going to go up. So ultimately, we want to try to reduce the number of dimensions, the number of variables that we have. However, we want to keep as much information as we can. There's a lot of different ways that we can go about doing this dimension reduction idea. We'll talk about it over the next several weeks. So one of the ways that we can do it is basic just domain knowledge, right? If a variable doesn't make sense, why would you put it in your model? So if I'm trying to predict a student's GPA, how tall they are is probably not an important variable. Assuming that we have, I mean, it could be an important variable if your age range is from 2-year-olds to 30-year-olds, then height could play a factor. But really what you're looking at is age, right? So thinking about just domain knowledge, if it doesn't make sense, don't put it in your model. Correlated variables, and this is where the multicollinearity piece comes in. Here, you can just eliminate one or the other. Now that we're trying to do prediction, you don't actually have to eliminate the multicollinearity, but you want to at least condense it, right? So if you have ACT and SAT, I'm picking on GPA for some reason today, right? If you have ACT and SAT, they're both highly correlated. Right? They're both a test of intelligence. Okay. But instead of having an ACT variable and an SAT variable, maybe you have an average, and I use intelligence loosely, right? But an average test, an average intelligence value. Add the two together and come up with an average. Maybe that is the variable that you want to use. So you're still containing all the information, but you're using a fewer number of variables. In regression, we can use regression models for dimension reduction. And this is something that goes kind of, like, students start to be like, are you serious? So you could theoretically, as we go throughout the semester and we're trying to do a dimension reduction, you could do a linear regression or regression equation first to find the best variables for the model. And then once you have those best variables, then do a different type of model, then do a decision tree, or then do a neural network. You can actually chain models together. Okay? So dimension reduction regression models have that dimension reduction capability. We've done this last semester, right? We tried the forward, the backward, the stepwise, a couple other options, but these are the most common. Okay, so we'll do that. So for your assignment, you'll actually get to do all of these in different softwares. Some of the software actually have dimension reduction nodes or options built in. Right? So SAS/EM has something called a variable selection node. And it's going to run, and really what it does, loosely, is it's running a regression analysis behind the scenes and saying, these are the variables that I think are worth keeping in your model, and these are the variables that aren't. And at this point, it actually uses an adjusted R-squared to talk about how much variability you can explain. Not our end goal, but for the variable selection process, how much variability is being explained by a variable is a good thing. For prediction, that I don't care anymore. But for variable selection, it's a good metric. The feature selection node in SPSS does something similar. These two nodes will use different techniques of how the software is deciding what they would recommend stays in the model or leaves the model. Because of that, if you use the feature selection in one model, it may say, you know what? Let's say you have 10 variables. This features or variable selection in SAS may say there's 2 variables I think are really important. These are what I use. You go to SPSS and it's like, you know what? There's actually 8. 8 that I think are viable candidates. Why don't you keep all these 8 and we'll see what happens later down the road. Okay? I'm not going to get into all of the math and stuff behind it. We're welcome to start to dig. A lot of it we just have to kind of dig into each node and see how it works. So the idea is that they exist, but you still have that common sense. Just because variable selection says don't use this variable, it's still just software. You still get to decide. It's like, but no, if you're telling me to use this variable, then I've got to use this variable too. Right? Just because of, again, that domain knowledge, what makes sense. So again, the whole idea kind of behind variable reduction is we're really just kind of trying to reduce the number of variables that we have to make our model more simplistic, more straightforward. The easiest model generally wins. So these are kind of how the variable selection nodes work. I will show you kind of what's happening. So this is SAS Enterprise Guide, SAS Enterprise Minor. So I'm teaching, so on Tuesdays and Thursdays, I teach basically the undergraduate of what I taught you guys last semester, and I use Enterprise Guide again. And so I say Enterprise Minor in that class all the time. And now I get here, and I'm like Enterprise Guide. So the SAS thing we're going to use, so Enterprise Minor. So what it'll actually do is it'll show you all of the variables, and then it'll say, you know what, reject these. Get rid of them. These are the ones that you shouldn't use. So for some of these, like the record ID, it's going to say, and then it'll give you like a reason, right? So here it has small r squares. So that's the reason it's saying to get rid of. One thing I noted on your assignment 1 that I just finished grading, so I asked, I won't say it's a trick question, but it was an interesting question. So in our churn data set, we have a customer, we have an ID value, right? It's not their phone number, right? Their phone number was a unique identifier, but then we also had like a customer ID that was a unique identifier. And one of the things that you had to do, right, you were trying to decide what type of variable is this? Is it categorical, qualitative? Is it continuous, quantitative? Some people said that ID was a numeric variable. Some people said it was a categorical variable. I had one person say, I don't really care because I'm never going to use it. I actually love that answer. Okay. So that was kind of a weird question because when it comes to record IDs, when it comes to customer IDs, when it comes to just a unique identifier that means nothing, right? You could make the assumption that it's nominal, that it's just a number that doesn't mean anything. You could make the assumption that it's ordinal, that there's probably some order to it, whether we know what it is or not. It's generally never, although it's made up of numbers, not really a numeric variable, because we're never going to do any type of math with it. In fact, we're never really going to do much of anything. Unless there's some really, really good reason, most of the time, anytime you see a record ID, you'll just automatically get rid of it. Should never show up in analysis. There's just, I mean, there's very, very rare cases where that will do it. So if you got that note, that's what that note means. So rejected error. Let's see what else we have. So other options that it'll show it, it'll say sometimes if there's too many missing values for a variable, the variable selection will say like too many missing values, we're going to kick that out. Yes.
Here's a question. So like on the churn set though, it's kind of nice to have the ID for like the distribution across the states. So you can see like, oh, we have this many customers in California, in Iowa. Or are we talking about something different?
I totally see where you're going. So I'm okay using the ID as far as like a count of customers, so like a frequency of customers.
Right.
that's totally fine.
But
you
need
just
a
won't
model.
use it, right, you won't use it as a model.
Right, okay.
Yeah, so for descriptive purposes, if that's something you're going to use to like count frequencies and things like that, absolutely. But as far as modeling, like you're never going to put ID as one of the variables in a logistic regression,
Okay.
or a linear regression, or a decision tree.
Right, so that makes sense.
Oh, we're going to break this on ID number this through this goes this way, and ID number this through this goes this way.
Right.
Unless it's something that is like, okay, this was customer number 1 that we ever served in our life. It's number 1, and now we're on customer 5,000. And so, oh, now we can see that customers 1 through 100 have this because they were our first customers
Right.
and our new customers. But by then, you can probably have another variable that's like all the new customers or times with company or something like that that would replace just the actual ID.
Yeah, okay.
But yeah, that totally makes sense. So thank you for that. Yes.
So how can ID be categorical? Because category is usually something which classifies, but for ID, like for every value, we can have only one. So we cannot actually say that it's a category under which something is going to be classified.
But it's not, so for me, so a numerical variable, a quantitative variable is going to be something that you do math on. So if it's something that you do math on, then it's a categorical variable, or then it's a quantitative, it's a continuous variable. For, like, let's say phone number. We'll come back to ID, right? So phone number, right? Everyone has a unique phone number, but it's not actually a numeric variable, it's a category. Now you only have one person per category, so it's not like you're necessarily going to be grouping them and creating, like your frequency of phone numbers is still just going to be 1. Right? Same thing goes with ID. So ID is going to be a classifier. We're going to use that to classify you as customer number 1 and customer number 2, as opposed to it's something that we can do math on. Does that help? Any other thing that you just, as we come across them, we'll talk about them. So again, so with our variable selection, things that we think of, if they have a small R squared, so it's not going to contribute much to any model, you might kick it out. If there's too many missing variables, or too many missing values, then it's like, you know what, there's not enough information in this variable to use it. Or sometimes if there's too many class levels, like phone number, right? That's the perfect example because like there's only, like there's 3,333 in the churn data sets, right? Because they're all unique. It's like, no, we can't do anything with this, it's useless. Let's get rid of it. So there's just some of the reasons that we might get rid of variables. Same thing, so it's just a different way to do it with this different node. We have to have a target variable, and again, it gets rid of things, too many missing values, too many class levels. It's just not going to contribute to a model. So we're going to play with these different softwares in the second half of class, which is why, but I just like to have some screenshots sometimes so you can go back and kind of get the big picture. The one thing that we're working on, I'm going to be very transparent with you right now. So SAS Via, SAS Via. The main thing that we're looking with at SAS Via right now is SAS Visual Analytics. SAS Visual Analytics is great. It shows us a lot of stuff. It's a wonderful way to get some quick information, be able to explain your models, compare your models. There's a lot of really great features. The one feature that it doesn't have really well yet It does, we just haven't played with it yet. It's some of the model cleaning, some of the stuff that I'm showing you right now. So, potentially at the end of the day today, I'm going to introduce you to an area that we do not have tutorials for, that you are welcome to play with, see what's what, as you start to explore. But we're in the process of building the tutorials to make all this work. We just got a data connection so that we can play between these two different pieces of the software. We just don't have the tutorials yet. So, full disclosure, you are my guinea pigs, but you're going to learn a lot as we kind of go through this. Let's go through this theory part real quick and we'll take a break. So, we've got a business understanding. We forgot about it because we talked about it 20 minutes ago, right? But we're going to try and figure out, can we figure out the charge per minute? Right? We've got our data cleaned. We're going to try this feature selection, see which variables we actually need to play with. Then we can actually model. Okay. So linear regression, you're going to see this slide every time I introduce a new concept to you. This is one of my favorite slides. I've worked really hard to try. Oh my God. I've worked really hard to try to make this fairly consistent throughout the semesters. This is your key characteristics for multiple linear regression. Okay. We're going to have a target variable. We're going to know what our target variable is, and it's going to be continuous. So if we go down our path, is this a supervised or unsupervised? Supervised. And then do we have an estimation or a classification? Alright, so we've got supervised, estimation task. Okay. So it's going to be model driven. When I say model driven, this means that we can make an equation. There's going to be a lot of the data mining methodologies that we go through that are not going to have an equation that goes with them. Okay, they're going to be data driven. This one in logistic regression is going to be model driven, so we can make an equation. Our goal here is we're going to predict target values and other data where we have predictor values but not target values. So our goal is trying to predict something new. So big overview, right? Given a set of predictor variables with an identified numerical target variable, we are looking for the best combination of predictor variables in our training set that's going to predict what's going to happen in our validation data set. Okay, so we're going to use different selection methods to help us determine a best set of predictors, right? Not the best, but a best set of predictors. And then we're going to use fit statistics to determine a best model. It's very similar to what we did last semester, but the difference is going to be the fit statistics that we use are going to change a little bit. Okay, so when we're talking about our interpretations, what do we need to talk about? Okay, we need to talk about the conditions of the best model. We're going to talk about the equation of the best model. And potentially we're going to do an explanation of our coefficients. Okay, so as far as the modeling process, as far as the interpretation process goes, it's very similar to what we did last semester. The difference, like I said, is mostly going to be in, right here, the fit statistics that we're going to use. And I'll introduce those in just a few minutes. So, really quickly, this is exactly what we did last semester, so just a very brief overview. We have our model. We talked about the residuals, where we're comparing our actual value from our predicted value. We had the hypothesis that we were testing. Right, so we were trying to look at, is there a linear relationship or not? So this was last semester. We had a test statistic that we used. We had some assumptions that we checked. Again, because we really cared about, does our model fit? How are we explaining? Right, so we wanted to make sure that we have these assumptions met. We're kind of looking at some scatter plots to tell that. That was what we did last semester. Just a very quick overview. For what I'm going to do today, because I can't just do your assignment for you as much as you'd like that, we're going to use the Boston housing data set. There's actually, if you get on Blackboard, I have the article that actually this came from. It's old, but it's kind of interesting. It's also one of the examples in your book. And so what we basically have here is we're trying to predict the median value of home or of owner-occupied homes in thousands of dollars. We're going to try to predict, given all this information in the Boston area, how much does this house cost. So if it's an area where there's high crime rate or low crime rate, then this is actually the crime rate, so the percentage of crime. Looking at the percentage of residential land that's zoned for big houses. Okay. Looking at pollution, nitrous oxide. Looking at how many rooms are in the house. Looking at, this is actually a categorical variable of does it bound the Charles River or not, right? You have a nice river view. Pupil to teacher ratio in the town, right? So just all these different values that you're looking at to see, can we predict the median value of the homes in the area? So we can do this, right? So this should look hopefully very familiar. And again, this is just a recap, hopefully it makes sense. If you have questions, stop me. So our review of multiple linear regression with our goal being explanation, we're trying to explain what's happening. I ran my model. I came up with an equation that LSTAT, if we go back, let's see what LSTAT stood for. The percentage of the lower status of the population, so lower status. So we start out with negative 1.4, we subtract 6.6 for our LSTAT, and then we add 5.1 times the number of rooms. So we have 5.1 is interpreted so that for each additional room in the house, we're going to increase our estimate by 5.1, or about $5,000. We've got an adjusted R squared of about 63%, so not the best, but not the worst. We also have this other number that we hadn't really looked at before. 5.5 is root mean squared error. So last semester, when we were trying to see explanation, we were focused on our adjusted R squared. How much of our variability will we explain? This semester, when we're talking about estimation tasks, we're going to focus on our root mean squared error. Does anybody know what that is? Brilliant, and I can tell you whatever I want. Okay, so our root mean squared error, or you can Google it, you'll find the same thing. The idea behind this is basically we're looking at the deviation between our actual and our predicted prices. So we're basically saying how far off are our predictions. You can get real technical, you can look at the equation that goes with it, but basically that's what we're saying.
So it's kind of like residual.
You use the residuals to get it, yes.
Oh.
The residuals are part of the calculation.
So if you're graphing it and you've got all your data points plotted and then you have your line, is that the difference between a point and a line? Or is that
So the difference between the point and the line is the residual. And so this is going to be roughly an average deviation of all of those points.
so you square it that way if it's negative?
Exactly. So you got, because your residual is you're going to overestimate, you're going to underestimate, right? So we're going to wind up doing some squares. Then we're taking the square root of it, so that way we get back into the same unit as what we're talking about, is what our dependent variable, our target variable is in. That's kind of the math behind it. The idea is going to be kind of what this means. So this we're saying 5.5. But we're talking about we're in thousands of dollars. So what this is saying is the average deviation is about $5,500. That's how off we are. Okay, so on average, given our model, we're going to be off by about $5,500. And maybe that's great. Maybe that's not okay. This is a very subjective number. Okay? Yes.
So it's not like the just our square, where it's like like oh, if it's in this range, it's good or bad.
Right.
This is like it just depends on.
It totally depends.
Okay.
Since squared is plus minus, you can be off that
Yes.
far in either direction.
Yes, absolutely. Right? So we can either we're either going to over or underestimate by about $5,500. Okay? So this number will let you compare multiple models. So if I compare, so this I just did, I don't remember what I did, right? But I came up with this model. So maybe I did backwards regression, I did stepwise regression, I did forward regression. So I have several different models. I can compare the root mean squared between models using the same data. Okay. What I can't do is compare this value to different data sets. It's like what you're saying. If I know my adjusted R squared goes between 0 and 100%. Once I get up in the, especially the 70s, the 80s, and I'm like, yeah, I'm explaining a lot of variability. Here, 5.5, right? This could have been, had we actually just changed the data, and instead of making it data number in thousands, we actually wrote out the thousands, then this root mean square would have actually been 5,540. Right? That's a huge difference than 5.5. Okay. So it's not about the value itself, it's about comparing the value amongst potential candidate models. So there is no wonderful if it's 0.7 for a correlation, it's strong. Or if so there's none of that. Okay, so it's really just used as a comparison tool between models on the same data set. So let's see, we have a regression equation. We can plug values in to make determinations, see the different residuals. I think now is the time to take a break. Okay. So that was kind of a recap of linear regression from last time, a little bit of a foresight into what we're going to do this time. We'll take a break.